Hello all, welcome to online class on problem solving using C. Today's topic variables and storage classes in C. This topic introduces how C programs manage data using variables and how storage classes control their behavior in memory. Every program depends on storing values, accessing them correctly, managing their lifetime efficiently. So here the learning objectives are: by end of this topic, the students will understand variables and their components, learn different storage classes, control scope and lifetime of variables, write memory efficient programs. The key insight: efficient memory management starts with understanding variables and storage classes. What are variables? The memory's address book. A variable is a named memory location that stores which can change during execution. There are three components of a variable: type, name, value. Type, which defines type of data, memory size, allowed operations. For example, int occupies 4 bytes, float occupies 4 bytes, char occupies 1 byte. Name, which is also called as identifier. Rules for this identifier: it must begin with letter or underscore, no spaces in between the words or letters, cannot be keywords. Example: valid, age, underscore, count, those are valid. Invalid means one num, total hyphen value, those are invalid. Value, actual data stored, it can change during execution. Like we can take int as equals to 25, float salary 45,050, char grade year. So in memory representation, variable address value, variable is 1025, salary 1004, 45,000.5, grade 1008 A. The key insight: variables acts as labels for memory locations, making programs readable and manageable. By storage classes, that is controlling variable lifespan and scope. Storage classes are C's way of giving you fine-grained control over how variables behave, where they live, how they survive, and who can access them. Without this control, programs would be unpredictable and memory insufficient. In a simple terms, we can say that storage classes define how variables behave in terms of lifetime, scope, and visibility. In this, we have three types: storage duration, scope, linkage. Storage duration: how long a variable exists in memory. So in this, we have automatic and static. Automatic exists during function execution, static exists throughout program. Scope, scope where a variable can be accessed. Global and local. Local means inside the function, global means enter the program. Third one, linkage. How variables are shared across file. In this also again we have two types: internal and external. Internal within one file, external across file. Why this matters? Without storage classes, name conflicts, memory waste, hard debugging. The key insight of these storage classes: it will give full control over memory and visibility. There are four pillars of storage classes. C provides four storage classes that define variable behavior: auto, register, static, and extend. So auto, the default for local variables, exists only within its blocks, created on entry, destroyed on exit. Register hints to the compiler to store the variable in a CPU register for faster access, no memory address available. Static retains its value throughout the entire program execution. Scope is limited but lifetime is permanent. External declares a variable defined in another file, enables sharing global variables across multiple sources. When coming to the memory area mapping, if the storage class is auto, memory area is stack. When the storage class is register, the memory area is CPU register. When the storage class is static, the memory area is data segment. When the storage class is extend, the memory area is data segment. So each storage class maps to a specific region. Auto and register, these are also called as the transient variables. So auto, the default local, register, the speed optimization. So auto is default for all local variables. It automatically created and destroyed. So its behavior exists only inside function, memory freed after execution. Register variables suggest storing variable in CPU register. Use it for performance optimization. So here there are some important points. Faster than RAM, cannot use ampersand operator, compiler may ignore it. Use cases, loop counters, frequently accessed variables. So, auto and register variables are temporary and performance oriented. Static and external. Static and external, or we can also call as persistent and shared variables. So static variable. So a static variable retains its values across function calls. For local statics, scope is limited to the function, but lifetime spans the entire program. Here the key features: retain value across function calls, initialized only once, stored in data segment. External variables use it to declare a global variable defined in another source file. The definition allocates memory and externally inferences it. So it enables modular programs to share state across files without redefinition errors. So why extern is useful? It supports modular programming, avoids duplication. Here the key insight is static means persistent, extend means sharing. Next, variables and storage classes. So the building blocks of your programs understand how C manages memory, scope and variable lifetime is essential for writing efficient bug-free code, which means error-free code. So this presentation covers everything you need to know within 15 minutes. So in this